to our channel PrashY. Learning is fun. In this module, we are going to learn how to draw ray diagrams for image formation by lenses from physics under the topic refraction of light at curved surfaces. We know that for every lens has two focus points, that is f2 and f1. To draw ray diagrams for lenses, we need two more points in addition to focal points f1 and f2. These points are equidistant from center of the lens and also equal to double the focal length. We call them as 2f2 and 2f1. For drawing ray diagrams related to lenses, we represent convex lens with this symbol and concave lens with this symbol. Though the lens have two surfaces, while drawing ray diagrams, we consider the lens as a single surface element because we assume that the thickness of the lens is very small. So to draw the ray diagrams, first we have to know various object positions. We have 6 object positions. Let us see the 6 object positions. First one is object at infinity. So this is the object where it is placed at infinity. Next, I am placing the object beyond 2f2. So this is the second object positions, beyond 2f2. Next object is at 2f2. I am placing the object at 2f2. Next position is object between 2f2 and f2. So the object is between 2f2 and f2. Next object position is at f2. I am placing the object at f2. This is the optic center. Now I am placing the object between optic center and f2. So this will become my 6th object position. So the object is between optic center and f2. So between optic center and f2. So these are the 6 various object positions. As the object is, we are moving the object from infinity to the optic center. Now let us trace out the images. Let's start drawing the ray diagrams for the object at infinity. When the object is at infinity, the rays that fall on the lens will be parallel to the principal axis. So let me draw the rays parallel to the principal axis. So first I will draw parallel lines parallel to the principal axis. So these rays, these are the incident rays. So these rays converge at a point on the principal axis. So this point is called as focus. The lens which we are using is a convex lens. So the rays are converging. So here the image forms at focus. So in this case the image formed is point size. Now let us observe for the concave lens. So for concave lens, let us see how the image forms. These are the parallel rays. So rays are parallel to the principal axis because the object is at infinity. So when the object is at infinity, we get the parallel rays. So these parallel rays are falling on the lens. These are the incident rays. So the incident rays are falling on a concave lens. So the rays will get diverged because the concave lens is a diverging lens. So the rays will diverge. So we will get the diverging rays here. So these are the refracted rays. So when I extend these diverging rays towards the focus, they all will meet at a point. Okay, they appear to emerge from focus. Okay, so all the rays, on extending these diverging rays, they all will meet at focus. So here this image is formed at focus F1. This is the image for concave lens. So when the object is at infinity, a parallel beam of light falls on the lens and when they converge for convex lens and they diverge for concave lens. Here the image is formed at focus. Here also image is formed at focus and here also image is formed at the focus. But here this focus is a virtual focus, right? So when the object is at infinity, we are getting the image at focus and the image will be point size. Let's tabulate. First one, the object position. Object is at infinity. When the object is at infinity, we got the image at focus. And the image characteristics is real, inverted, and diminished image. Real, inverted and diminished. So in shortcut we will write it as RID. Read. And it is point size image. Point sized. Diminished means smaller than the object. So that is still smaller than the object, that is point size image will form at focus. For concave lens, the first one is object is at infinity. Image will be at focus. And here we will get virtual erect and diminished image. Virtual, erect and diminished. So in short we will write it as VED. Virtual, erect, diminished. So now let us see the ray diagram for object placed beyond the center of curvature on the principal axis. So let us first check out for the convex lens. So I am placing the object beyond center of curvature, that is 2F2. So when we need two rays to trace the image, so let us first take the ray which is passing through the optic center. So we know that the ray which is passing through the optical center proceeds undeviated. So first of all I will take the ray which is passing through the optical center. So from the top of the object I am drawing a ray which is passing through the optical center. So this is my incident ray and this is the refracted ray. Right. Now we need another ray. So I am taking another ray which is passing parallel to the principal axis. So a ray which is parallel to the principal axis. So this is on the convex lens. So this is our incident ray. So ray which is passing parallel to the principal axis always meets at the focus. So it meets at the focus. So remember these 2 points, children, always. When a ray is passing parallel to the principal axis, it always meets at the focus. Now extending these two rays, they intersect at a point. So this is the point of intersection of these two rays, and here this point gives me the image. So I will draw the normal to the principal axis. So now this is my image. So this image I will get it as inverted image, that is upside down. So when the object is placed beyond 2F2, I am getting the image between F1 and 2F1. So for convex lens, second one is object is beyond 2F2. So beyond 2F2. So when the object is beyond 2F2, we got the image between 2f1 and f1. So the image characteristics, what is the image characteristics we got? Here we got real, inverted. Inverted means upside down, inverted, and diminished. That means smaller than the object. Diminished. Real, inverted, and diminished. So here also we will get in shortcut, we will write rid. So but here the image form is not this point size image. It is just somewhat smaller than the object. That's it. For object placed beyond the center of curvature on the principal axis, we have completed convex. Now let us come to the concave. So here also I am placing the object beyond center of curvature, that is 2f1. Beyond 2f1 I am placing the object. So this is my object. So again I am taking two rays. So ray 1 is passing through the optic center, and though whether it is a convex or concave, the ray which is passing through the optical center is always undeviated. So the ray gets undeviated. Next, second ray I am taking parallel to the principal axis. So parallel to the principal axis. Since this lens is a diverging lens, it starts so the ray gets diverged. So the ray gets diverged. Okay, now I have to extend this to meet at the focus, because we know that the ray which is passing through parallel to the principal axis always meets at the focus. So I am extending it to the focus, and here there is a point intersection of these two rays. So at the intersection of these two rays we will get an image. So this image is very small image, and that we are getting an erect image which is virtual. So the image formed by concave lens is a virtual, erect, and diminished image. So for the second object position, we have object is placed beyond 2f2. When the object is placed beyond 2f2, we got the image between optic center and f1. So we got the image between optic center and f1. f1 means focus, and image characteristic we got is virtual, erect, and diminished. So here also we are getting in shortcut, we are getting VED, V-E-D, virtual, erect, diminished. So now moving to the third object position, that is object placed at the center of curvature. So when the object is placed at the center of curvature, let us trace the image for first convex lens. So again I am taking the same two rays, which the ray is passing through the optical center. This is our optical center O. So a ray passing through the optical center, we know that it always moves undeviated. So it passes undeviated. So this is my incident ray and this is my refracted ray. Again I am taking another ray which is parallel to the principal axis. So parallel to the principal axis. Parallel to the principal axis always meets at the focus. So the ray is passing through the meeting at the focus. So these two rays will intersect at this point. So at this point I am drawing a normal. So this is my where I trace the image. So when the object is placed at 2f2, I am getting the image also at 2f1. So here the size of the object is same as the size of the image. Okay, so this is my incident ray and this is my refracted ray. So the third object position is object is placed at 2f2. So when the object is placed at 2f2, we got the image at 2f1. And here the image characteristics is real, inverted, and same size of the object. Real, inverted, and same size. So in short I will write as RIS, real, inverted, same size. The object placed at center of curvature. Let us see the image for concave lens. So I am placing the object at 2f1. on a concave lens. So I will take the same two rays, a ray which is passing through optic center. So this is my optic center. So ray passing through the optic center always proceeds undeviated. So it proceeds undeviated. So this is my incident ray and this is my refracted ray. Another ray I am taking which is parallel to the principal axis. So parallel to the principal axis. So parallel to the principal axis. So it is a diverging lens. So the ray gets diverged. So I am extending these rays so that they can meet at the focus. So here is the point of intersection. So this is the point of intersection. At the point of intersection I have to draw the image. So here I got an erect image and which is virtual, and the image is formed between optic center and F1. So when the object is placed at 2F1, I have got the image between optic center and F1 for a concave lens. So object is placed at 2F1. The image position is between optic center and focus. And the image characteristics is virtual, erect and diminished. That is nothing but VED. So now let us trace the image for the object placed between center of curvature and focal point. So between center of curvature, that means 2F2 and F2, I am placing the object. So this is my object and this is my optic center. So now a ray passing through the optic center proceeds undeviated. Another ray I am taking parallel to the principal axis. So parallel to the principal axis. This is my incident ray. So parallel to the principal axis always meets at the focus. So the ray is passing through the focus. Now if I extend these two rays are meeting at a point. So at this point I'll get the image. So I am drawing a normal to the principal axis. So this is my image. So when the object is placed between 2F2 and F2, I got the image beyond 2F1. Beyond 2F1. And here if you see the image size is greater than the object size. Okay, so this is my object and this is my image. So the lens we used here is a convex lens. So for convex lens, fourth one, object is placed between 2F2 and F2. So we got the image beyond 2F1 and here we got the image as real, inverted, and here we have got a magnified image. Magnified image. So I will write it as RIM, real, inverted, magnified. The object placed between the center of curvature and focus point. For concave lens, let us see. So the object is placed between 2F1 and F1. So this is my object. So a ray passing, this is my optic center. So ray passing through the optic center. Again the same rays passing through the optic center proceeds undeviated. So this is my incident ray and that is the refracted ray. Again another ray I am taking parallel to the principal axis. So parallel to the principal axis, because this is a diverging ray, so the ray gets diverged, and on extending towards the focus, so I have got a point of intersection between F1 and O. So here I am getting the image. So when the object is placed between 2F1 and F1 for a concave lens, we are getting the image between O and F1. And the image formed is virtual, erect and diminished. Diminished means smaller than the size of the object. So fourth one, object is between 2F2 and F1 and F1. So we got the image between optic center and focus. So the image characteristics are virtual, erect, diminished. So here also we will get VED. So now let us look into the another object position, that is object is placed at focal point. So when the object is placed at the focus, again the same two rays I am taking. This is my optic center O. So passing through the optic center, proceeds undeviated and parallel to the principal axis. Parallel to the principal axis, always meets through focus. So here if you observe, these two rays are parallel, so we will be saying that these two rays will meet at infinity. So when the object is placed at focus, image will be formed at infinity. So here this is the image formation for convex lens. So fifth one is the object position is at focus. So at focus, and image we are getting at infinity. So the image what we got is real, inverted and magnified. Real, inverted and magnified. So in short we will write as rim, but here because the image is forming at infinity, we will say that the size and the nature of the image cannot be discussed, because since we are saying that the image is formed at infinity. The object is placed at the focal point. Let us see for the concave lens. So object is placed at the focus. This is my optic center. So passing through the optic center, ray proceeds undeviated. So if you have observed children, I am taking the same two rays. The ray 1 is passing through the optic center and ray 2 is parallel to the principal axis. So I am using these two rays to get the image formation for all the cases. For all the object positions, I am taking the same two rays, if you observe. Okay, so I am getting the point of intersection here. So at this point I will get the image. Here also I am getting erect image which is formed between optic center and F1. So when the object is placed at F1, I am getting the image between optic center and F1 for a concave lens. So the fifth case is object is placed at focus. So when the object is placed at focus, I am getting the object image between optic center and focus. So here also I am getting virtual, erect, diminished image. So here also I am getting VED. Now moving to the sixth case, that is the last case, when the object is placed between focal point and optic center. So when the object is placed between O and F2. So again the same two rays I am taking, passing through the optic center. And another ray which is parallel to the principal axis. Parallel to the principal axis, meets at the focus. So if you observe, these two rays will never meet. So what I will do is I will extend it towards the back side. So this side I am extending these two rays so that they may meet somewhere. So this is one extension, and the second ray also I am extending. So I found that these two rays on extending, they are meeting at a point. So at this point I'll get the image. So here I am getting an image which is greater than the object, and it is forming behind F2, and this is my image and this is my object. So here I am getting virtual image. So first time for the convex lens we are getting virtual image. Okay. Case 6 is a special case where we are placing the object between F2 and optic center. So when I place the object between F2 and optic center, I got the image behind F2. So the image is formed on the same side of the lens. Okay, and it is behind F2. Behind the focus, if I say behind the focus. So here the image formed is virtual, erect and magnified. So I will write it as VEM, virtual, erect, magnified. Just trace out the image for the object placed between focus point and optic center for a concave lens. So I am placing the object between optic center and focus F1. So a ray passing through the optic center proceeds undeviated. So this is my first ray. Second ray is again parallel to the principal axis. Gets diverged and meets at the focus. So this ray gets diverged and it is meeting at the focus. So if I observe that these 2 points intersect at a point, at the point of intersection I am drawing the image. So the here image formed is virtual, erect and also diminished. And here also the image is formed between optic center and F1. So sixth case, and the object is placed between focus and optic center. We are getting the image between optic center and focus. And here also we are getting virtual, erect, diminished image. So here also we are getting VED. So on observing the 6 cases for convex lenses, when the object is at infinity we are getting at focus. When the object is at focus we are getting at infinity. When the object is beyond 2F2 we are getting between 2F1 and F1. When the object is between 2F2 and F2 we are getting beyond 2F1. So at F2 you are getting at F1. And this is a special case where we are placing the object between optic center and F2. We are getting the image on the same side of the object. And when coming to the image characteristics, here we have observed that all the 5 cases, in all the 5 cases, first 5 cases, we are getting real images. And we know that all real images are inverted. So real inverted images are formed. And so for the first 2 cases, we are getting diminished image. Third case we are getting same size, and 4 and 5 cases as magnified image, and finally 6th case we are getting virtual, erect and magnified images. So from this we can say that convex lens can form both real and virtual images and both diminished and magnified images. To concave lens, so here we have taken the 6 object positions, but for 6 object positions we have got only 2 differences. One, when the object is at infinity, we got the image at focus, and all the image characteristics are virtual, erect and diminished. That means all the image characteristics are virtual, erect and diminished images. So concave lens always forms diminished images. Next, and for all the other cases also, wherever you place the object, the image is forming at the same place, that is between optic center and focus. So for concave lens, even though we are drawing the image positions for all the 6 cases, the image position is the same. So for whatever be the object position, image will be between optic center and focus for a concave lens. Hope this module will help you in drawing the ray diagrams. Thank you.